Welcome back to Goliath. Today we're talking about a new Zephyr feature called ZBus that we just saw pop up as a new merge feature. We're really excited about it. It provides some interesting kind of new capabilities into the Zephyr ecosystem, which we know and love here at Goliath. We saw the author of ZBus was Rodrigo here, and we asked him to come and talk about it. So welcome, Rodrigo.
Oh, thank you. Thank you.
Could you tell us a
Thank
little
you,
bit
Chris.
about your background and how you got started with the ZBus?
Okay. Uh, my name is Rodrigo Peixoto. It's hard to talk and speak in English. I don't know. I am a professor at the university here in Brazil. I have a background on I am a computer engineering, in fact, computer engineering, and I have background in mobile and embedded systems. I work with embedded systems. I don't know, for 8, 9 years, I guess, and I teach that on the university. At the university, I I I make some. I'm part of the laboratory here at the university, and there we have a kind of, we are a kind of innovation center. We interact with the industry, make some innovations and products to them. And I recently, 2 years ago, I started my PhD, and I decided to use part of my work. ZBus is part of my work, my daily basis work, and to provide some solutions to other companies, to the community, in fact. And I decided to use that, and my PhD is on, in majority, it's a kind of software engineer for embedded systems, in fact, and ZBus is
Yeah.
part of it.
Right. So we were remarking before we started recording that this does feel like, so this is like a pub sub publish subscribe kind of model. It does feel like this is like a, or event driven. We'll get into all that stuff, but it does feel like this is kind of like the continued software engineering making its way down into embedded systems, which you said
Yeah,
is kind of your background. That's really
yeah,
great.
yeah, for sure. Yeah, I'm trying to improve the way embedded systems, IoT devices are developed. I I I I could not find a lot of things on this area, in fact, and we have to rewrite a lot of things, reinvent the wheel all the time. And I would like to help the community to make better software and thing like that, right?
Yeah, that's great. So we're going to have some visual aids here because you put a lot of really great uh, rich content in your pull request, and so that's always useful to get a good background on things that we're doing here. Let's take a look at that, and maybe we can kind of go through and use that as the basis for our discussion as well. So I'll just turn this into a slideshow. Hopefully, it goes to the right slide. I think one thing that would help me is maybe I think it's this one, but it's basically like this is the new scenario, or this is the new example. What is
Yeah.
the comparison point? So like we have this new method, new ZBus pub sub architecture, but what is
Okay.
the old way of doing things that we can use as a basis for the discussion?
I guess in the second slide, if you could go there, we have a kind of visual. Yeah, this one. In the beginning of the current way before yesterday, all the in this case is a desktop scenario where process talk each other directly. So if you have one processor, you have to know the other processors and process and talk directly to them and make a kind of coupling. All of
Hmm.
them need to know, and you have to connect one to another, and it's not so easy to do because you have to choose why do you, how do you make them talk, right? If
Yeah.
you go
So
to the
so
next
just as
slide.
to give it an example of maybe something that is in this. So like when I have a timer process kick off, and I say like at the end of a software timer at 30 seconds, whatever, it does a timer callback. I usually then call like a worker that goes and does some work. Is that one of
Yeah,
the processes that is that a good example of a process here, like a single process?
yeah, but in fact, if you go to the next slide, I show you the this is the dbus. Dbus is almost the ZBus, but for Linux, right?
Okay.
It's
Okay.
almost the same thing, but dbus is really more powerful and heavy, and complex, right? And the next slide, sorry.
I should have just let you. Yeah, I should have. Yeah.
Yeah, this is the proposal. In fact, in embedded systems, we have threads instead of process, right?
Mhm.
And nowadays we have some threads on our firmware, right? And the threads, when we want to make a thread to talk to another thread, I don't know, we need to use a mailbox or message queue
Sure.
or
Yeah.
FIFO or something like that. You need to
Yeah.
choose one and make this work. But when you have thread B talking to thread C via, I don't know, some message queue,
Yeah.
you have to
Yeah.
have a message queue where using between them.
Yeah. It's
And
like a singular pipeline from one to the other, right? So
yeah, yeah,
you don't get to say everybody go do this stuff. It's just message C or thread C go do
yeah.
this thing.
Yeah, and if you need some response, you need to have another message queue in the other direction, right? And
Right.
it's not so easy to make a decoupled thing there. So when I'm talking about decoupling, you have that on microservices with event-driven architecture and other things that the bus enables, right? So in this scenario, ZBus and perfect, great timing. In ZBus, we have threads and callbacks, and you said in our previous talking about publish subscribe. We have that on ZBus, but we have already as well message passing, because sometimes you need to act quick, right? You need to act every time something changes. You need to quickly respond to that,
Mhm.
right? And we have synchronous response and asynchronous response,
Mhm.
and we have, in this case, we have callbacks and threads talking to the bus, and it's really powerful. But we have to talk more to you understand more details about that. But it gives us a kind of decoupling in time, space, and synchronization. So thread A, B, and C, they don't need to know each other. They don't need to wait for the communication work, and they can work on other tasks between the
Right.
communication. So this is a perfect scenario for asynchronous and event-driven stuff, right?
Yeah, so that kind of makes sense too, because when I think about like message queues, we've done some writing about message queues as well, but it's often because in a in a single threaded, which is not necessarily the only thing we do these days, but in a single threaded environment, you're often waiting for some other process to run, and so you're waiting on this. You put it into a message queue because you don't know that you don't want to wait around for it to be done. You're just kind of putting it into the queue, and then you go off and do your own thing, and
Yeah,
it's so
yeah,
it helps to do that decoupling, like you're saying. So now this
yeah.
is another way to do that decoupling.
Yeah, yeah, for sure. And in this case, when we talk about message queues, we have a kind of coupling there, because in this case it's code coupling, because you need to know who is producing and who is consuming in some way, right?
Ah, yeah.
But there are some other details about it, but here we are trying to solve this kind of thing and make a unified way to make threads talk in a easy way, right?
So does this also lead into larger embedded systems as well? Because I would imagine, when you have two threads, you could just kind of set everything up, maybe three, but then you start to get like that cross hatching of like different things talking to one another. But when you get to 1,000 threads, which for time, a 16 kilobyte memory part is different than like
Yeah,
some
yeah.
modern microcontroller that's like 600 megahertz. So like, does that help to grow the systems as well?
Yeah, for sure. It's part of the system, and if you go down a little more on the presentation, I just tried to show that we are ZBus is a channel based communication
Mm,
message bus, in fact. So everything that we have is channel, and the channel has messages and so forth. But this what you are saying, it was a request from the community during the RFC process. And with ZBus, we have a kind of virtual distributed event dispatcher. In fact, we don't have a centralized event dispatcher. This is a really interesting feature, because in this way you can have several contexts running in parallel without interfering one to another, right? Because the event dispatch is not made for, I don't know, for one instance or something like that. Every thread or piece of code that published to a channel makes the notification process. So this is a kind of, we distributed the event dispatch logic to every part of the system that publishes. So this enables the scales up what you need, I guess. So the ZBus thinks in small 16 kilobytes devices, and big systems with a lot of threads and everything else.
So this is the virtual dispense.
Yes. Yes.
VDED.
Yeah.
More acronyms. Here we go.
yeah. A little more.
If ZBus isn't an acronym yet, we should just should backdate it to be an acronym.
Yeah. The VDE is a feature that was part of a discussion during the pull request, right, process, because before I had one single instance making the dispatching, but it was not so good, because sometimes I don't know, a low priority context could interfere in a high priority context, because you just have one event dispatcher. But in this way, you can do in parallel without interfering, because the thread N2 has more priority in size here, and the communication can go there. And when the CPU is in idle mode, you can make the thread 4 and 3 to talk, and it's really independent, right?
That's great. Well, this is my favorite slide here, the common scenario, because I'm all about boots on the ground kind of thing. So this is good, because this kind of gives me like the what's going to happen here now.
Yeah, this is a really common scenario when you are I don't know, writing something to IoT or the common connected devices, right? You have a kind of trigger that start some processing, some sensor fetch or something like that. In this case here, I have a timer. I don't know, 1 second, 5 seconds, 1 minute. I don't know. You prefer. And every time that the time is triggered, it sends the work queue a work to start a trigger, and the work queue doesn't need to know sensor thread, right? It just publish to the channel start trigger, and yeah, every observer that needs to know the start trigger changed will subscribe to that, or observer subscribe or listen. I some details, and in this case, the sensor thread will fetch the sensor data and put the data in the sensor data, right? Makes sense. And the core thread is observing the sensor data. We collect the data, and I don't know, put that on a buffer or something like that. I don't know, to aggregate some hundreds of thousands of readings to make some sample.
Yeah, write it to an SD card or put it to a screen or something else that you might want some local processing of it as well, right?
Yeah, for sure. And after the data, when you have the enough data to send to the cloud, for example, you create a payload with the data and publish to the channel payload. And every
Rodrigo, I got to say this is very reassuring because this is kind of how my stuff is structured, and it makes me feel a little better about my code. I don't have the ZBus in there, obviously, but I'm doing things a little bit okay.
That's good. Yeah, and after that, the LoRa thread that is observing to the payload will send the information to the cloud, and after the confirmation or something like that, it will publish to the transmission done. This is a really full example, and the blink callback here is blinking when the trigger is is changed, and the transmission is done. If you need to blink in other scenario, you could do, but the blink callback doesn't know any thread, right? The LoRa thread just know the payload channel and the transmission done channel. So
So from the perspective of the blink, does that mean I'm just saying just listen for the trigger and just listen for the done, and that's all you have to do? Is that kind of the idea,
yes,
like the kind of the pseudocode idea?
yeah, just listen. When it changed, run the blink callback. Just this.
Yep.
So
Great.
all the time the start trigger change, the blink callback is executed, and the transmission done is the same. Right. So it's really straightforward to do this kind of thing on ZBus, and you can have this kind of thing. And if you go, I don't know, 2 slides more, I guess.
Okay. Let's see.
Yeah. You can have this kind of thing. You can switch the trigger from a timer to a button, for example.
Oh, sure.
You can switch the LoRa to Bluetooth, and you doesn't.
We do thread often at Goliath, so that's actually the sample I was talking about. That was a thread. Our red demo. So
you can do
sending a thread.
Yeah, you can do whatever you want here, without changing the sensor thread or core thread or blink callback, right? It's really powerful in this way. And sometimes you need to verify if the blink callback's working properly or something like that. You can add a mock and analyze the message changing on the time. You can do a lot of things. If you go back one slide, I listed some pros and cons about ZBus. ZBus promotes a event-driven architecture. It's really interesting for code. You can see that on microservice. You can see that on the desktop development. You can see this kind of thing working really well on other kind of systems, right? And why not?
I would think, since most of the people watching this and just generally using Zephyr are like firmware and hardware engineers, I would think event-driven state machines as well, right? So you can set up state machines in multiple ways, but event state machines are like, I think, kind of burned into the brains of firmware engineers. This is just going to be a slightly different version of that, in the fewer of the circles in the state diagrams, but the same kind of ideas.
Yeah, and you can do that. You can use the state machines using even from ZBus, for example, for channels, and you can do a lot of things. But it's a kind of a different approach. You can do a lot of things. Event driven is really interesting. Another pro. Sorry.
Yeah, you say in the cons here, you say no delivery guarantees. Is there anything built into ZBus that is that does so? There's no error checking or like, or do you have to write that error checking yourself to see that it's executed and do additional like publish back onto the bus to say I sent out this message? So like for example, with like Thread and Goliath, right? You might be sending a message over Thread to Goliath, and you can get a response from the server that says, yeah, I got the latest message here. But then I would have to then specifically publish that back onto ZBus so that maybe the core knows that this message was successful.
Yeah, when I say no delivery guarantees for subscribers is about the fact, because in ZBus we have this kind of thing. We publish to a channel. When the channel changed, right, the event is sent to all the subscribers. Remembering here, we have subscribers and listeners. Subscribers are asynchronous observers,
right.
right?
Mhm.
And the listeners are synchronous observers. During a publishing, we have all the listeners executed. So the delivery guaranteed for listeners is all the time the delivery is
Mm,
guaranteed for listeners, but the subscribers only receives the notification that the channel changed.
got
So
it.
when you send the notification, if you have a high priority thread that publishes again on that channel, the first data is lost, right? So
Mm,
the subscriber will be notified again, but only the last data is recorded on ZBus.
got it. Got it.
We have a kind of one slot cache there that stores the last publishing data, right? So because of that, we say that there is no delivery guarantees for subscribers.
I see.
But
Okay. Yeah.
in scenario you said you were talking about, we can have two channels, one to send or other to act, and you can make the confirm message to work, right? But on the channels we don't have confirmed messages. You just
Yeah.
publish, and the event dispatcher, the VDED, will dispatch all the information to the system.
Yeah, it does sound like, I mean, so in general with ZBus here, it does sound like this is a, kind of higher complexity kind of system anyways, right? I would imagine this is not something that someone's going to jump into when they're blinking their first LED with Zephyr.
Yeah,
But then understanding your own architecture on top of this, it additionally will help people to like to take a second look at like, oh, this is a subscriber, is this like a critical piece of data that you need to understand? If so, then maybe consider this other way of architecting your system and your setup, that sort of thing.
yeah. ZBus is not for Hello World or something like that.
Yeah.
This is a kind of tool that you need to use when your system is going to be complex, right? So you have a lot of threads, you have a complex data sharing between them, you have some communications approach, and this is the place to use ZBus, right?
Yeah,
But
definitely.
but for simple systems, ZBus will be a good fit if you a good fit if you need to simplify the things, and if you study ZBus, you don't need to study event queue, or
Right.
message queue, FIFO, a lot of things for the majority of the systems. But sometimes you need to use a message queue. In fact.
Yeah. So one other thing I wanted to call out is that you have been doing a lot of testing here. You have some stuff in here from this is Procepio, I think it's called.
Yeah,
You said,
Percepio and
yeah,
Personalize. Yeah,
yeah,
uh, uh,
yeah,
uh,
yeah,
I,
yeah,
I would like to thank
yeah.
they to provide me the license. This is an academic license. I'm working on to show the ZBus working on on in details, right?
Yeah.
In this scenario, there we have, I don't know, if you go one slide up, yeah, you can see the sample. This is a sample on the we have that on the repository, uh, and this is a really simple one, a really simple one, where you have the producer producing some data published to the raw data, and there is a kind of callback, a future that process data and publish to the process data, and the consumer can use that. And with the ZBus, you can in runtime change the way this is used. If you go two slides down or up, yeah,
Oh, down this way.
yeah,
Yeah.
that's good. You can remove the filter from there and bypass that, and read directly from raw data.
I see.
The consumer
Yeah.
can, yeah, you can do this in runtime, right? This is a feature requested on during the submission, and
Mhm.
I added that, and it's amazing because you can do runtime observers, and the
Ah,
observers can be added or removed from a channel, right? So this is possible, and that chart you were showing, I guess, one before. Yes,
Yeah.
this one. The yellow signals there, you can see ZBus is a kind of
Mm.
showing the publishing process. You have the consumer, you have the producer, Zephyr, main, and a lot of things.
Turning my head here as I'm reading on my screen. Yeah.
Yeah, we can do that in vertical, but you cannot
Yeah.
see all the
That's right.
events.
Yeah.
Yeah,
Yeah.
but there we are showing that we have a kind of sequence to the notification sequence. And if you go, I don't know if up or down, you have some codes. I
Oh
I
yeah, I saw
think
that further
it's
up.
up.
I think.
Yeah,
Yeah.
yeah. I one more. Yeah, there you have two channels. You have the
Hmm.
definitions of the channels, right? The raw
Hmm.
data channel, the process data channel. The
Yep.
channel is about the message format. The message format can be everything you need. I don't know. It's a valid C type. You can have structs, unions, or even
Hmm.
integers, but booleans, whatever you need, right?
Yeah,
The
this looks
next
great.
two, yeah, the next two arguments there, the new are the validator. If you need to validate the message before publish, if the I don't know if the information is just valid from 0 to 100, for example, you just define a function that validates and put there, and all the data exchanged by that channel is valid uh, based on that function, right?
Yeah.
The next one is a user data pointer. If you need a reference, if you need add some extra data to the channel, you can point it here. So it enables us to extend the ZBus capabilities. We have a lot of extension and flexibility possibilities there, because we can use even we can even exchange information from a ZBus on the embedded system, and the ZBus on for example, on a Renode emulator
Mhm.
running, because we have a kind of an extension and that enables that. So this is a channel, and when you are trying to use the channel, you just need to publish or read or claim. There are a lot of things, and
Yeah.
if you go back to the the,
Let's say
the
there's
pro,
a whole documentation piece on the Zephyr docs as well that shows here
yeah,
and that sort of thing as well, some example code and stuff like that.
yeah, we have a lot of things there, and one of the cons is the complexity, because we have a lot of things to learn.
Hmm.
And I think if you go back 2 slides, is the pro and cons.
Oh, this one. Yep. 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 Yep.
Yeah, yeah, yeah. And keep going on this part. We have an unified way to make threads to talk and share data. This is in the pro side. This is another interesting part, because with ZBus you can share data, not just make some communication, in fact, but you can share data, because you can put some data on the channel and keep that, and all the threads that need that data can read that channel. So you are not using that to communicate, but to store data and share data between the threads. It's possible as well. You have code decoupling. It promotes reuse, because if you are developing some thread that doesn't use hardware, you can put that same thread on other device, but
Hmm.
you just need to have the same channels, right? So you can reuse a lot of code, and I guess it's really interesting. ZBus increases testability, because we have more controllability and observability, because you can create mocks, and the mocks can observe and change the information of a channel. and we have a lot of flexibility and extensibility. The cons, we have a take time to mastering it. It's not so easy because you have a lot of possibilities. You have synchronous, asynchronous, you have listeners, subscribers. We have a lot of things because when you are talking about a community like Zephyr, we have plenty different kinds of
Yeah.
systems and complexities, and we cannot. It's not so easy to have a chip beautiful and everything. It's not
Yeah,
so easy.
yeah. I think
So
the scale differences of different hardware that can run Zephyr is it's pretty intense. You know, it's a very disparate from the high end to the low end, and so I'd
yeah,
imagine that
yeah,
also feeds into this.
yeah, for sure, for sure. And it's not for intensive byte stream, right? Because if you need to transfer some intensive data stream, I would suggest you to use pipes or message queues. In fact, it's
Yeah,
not for ZBus
got it.
and not
And
the.
also, what about like DMA type stuff? Couldn't you kick off a DMA thread though using ZBus?
The DMA, I don't know, in fact, because the DMA can be used to. Yeah, good question. Because the DMA is in a different level here, right?
Hmm.
But
I
I
just
guess
imagine a thread that was sitting there like waiting for a new. So like say I had a timer go off. So if we go back to this one here, I have a timer
okay,
go off. I take a sensor reading. I sensor data, and then I have another listener maybe in place of core thread. There's a DMA thread just saying wait for wait for a sensor ready to go, and then it goes out and it fetches a bunch of data. That's when I think of like DMA type of things there, but it probably wouldn't be going through DBus or ZBus. It'd be going kind of parallel and talking to one another.
yeah. You can use that on the thread implementation, right?
Hmm.
The ZBus doesn't use DMA directly, so you
Hmm.
can, I don't know, the copy data you can do using the DMA, but it's not
Yeah.
implemented directly on ZBus, right?
Yeah. I think ZBus wouldn't be I don't think people would, other than the messaging to say that it's ready to go take a reading sort of thing. But then
Yeah,
maybe
yeah,
you could do that interrupts as well, that sort of thing. This
yeah.
is really great, Rodrigo. I think this is I could see this having a big implication in the stuff that Goliath's doing, and just generally. Where would you say that people should start with? So like, what's the first thing people should run when they're interested in trying out ZBus?
Yeah, I would suggest to use to take a look at the samples. I did a lot of
Hmm.
samples, and one of the hardest part of the pull request was I have 6 samples, I guess, and 5 sets of tests. So every time I did some change on ZBuzz, I had to change a lot of things
Hmm.
and make every yeah. You have several samples, and maybe sometimes if the samples doesn't help, the community can go to the tests and take a look at that. But I guess the documentation is a good point.
Yep.
The presentation is available as well.
Hmm.
The presentation
Yeah.
is
So we'll,
available
we'll
as
have
well.
links to both of these in the accompanying blog posts that's with this video, so people should definitely check that
Okay,
out.
okay.
Yeah, that's great.
Yeah, and I am preparing a video about it, explain and showing the hello world, some complex samples, and I guess it's going to, I don't know, soon I can share this link of the video and other resources about it. But for now, I guess the documentation, the samples can help a lot and make their life easier to start
That's great.
using ZBuds.
All right. Well, thanks so much for coming on and telling us about this today. Really appreciate it. We appreciate your hard work on this. We saw it was 4 years in the making, so seems
Yeah,
like
yeah,
it's yeah, that's a nice hard slog there to keep pushing this
yeah,
forward. So that's really
yeah. The,
cool.
the, the first version, it was a long time ago for a system I was developing with a lot of properties, and I at that time I developed a property system that is similar to your setting. settings systems, right?
Mhm.
And
Yeah.
I changed. When I thought it's ready to go, I started the pull request, and it takes 4 months to to be merged because
Yeah.
of the community requests, and all the requests were really good, and now the ZBus is a really better version than the first one
Yeah.
I put there.
Yeah. That's a triumph of community, which we continue to really promote here at Goliath. So thanks again for all your work. And yeah, we're looking forward to seeing more stuff with ZBus.
Okay, thank you.